Hello, my name is Colleen Lewis. I'm here to share our experience report, Physical Models of Java Inheritance. And on this project, I worked with my colleagues from Math for America Los Angeles. That's Manuel Hernandez, Angel Kuo, Hannah McDowell, and Nathan Roller. As part of Math for America Los Angeles, we've been collaborating for years, trying to make it easier for our students to understand how Java works. You can find information about all of the strategies we've developed at csteachingtips.org/3D or at that tiny URL /3D Java resources. Here, we'll just focus on the stuff specific to Java inheritance. So for everything I'll talk about today, we have videos available. For example, those links I just mentioned will point you to a YouTube playlist that has all of the content. Our experience report is structured around the different parts of how we introduce inheritance. And in the paper for each of those, we tell you our sort of instructional overview. That is, how do we engage students? What's the active learning component? How do we sequence the information? Then our observations, sort of what seems to work about that sort of eventual approach that we landed on. Some challenges we're still facing when we're teaching that exact content from that part of our lesson. And then maybe the really fun part is all of our failed attempts. So how is the instructional approach that we've taken now and developed over many years, how does that differ from some of the other approaches that we've tried that didn't seem to work and why we think they didn't work? Okay, so you'll get all of that content in the main paper. What I'm going to do here is show you our 8 tips for teaching inheritance. And these 8 tips try to capture sort of the evolution of our process of how we collectively teach Java inheritance to our students. Okay, our first one is distinguish the variables and objects type. So a key idea for students is that there's a difference between the type of a variable and the type of the object. That becomes really important when we think about how the type of the variable determines whether our code compiles, and the type of the object determines what methods we actually call. Before we get to inheritance, in Java, students really don't have to pay attention to this. So we start with a warm-up example to review null partially. So we show them the code here and we say, draw a diagram of what this would create. Our students are used to drawing diagrams that look something like this. So you can see C1 references a cat object and C2 is null. We also in our class use physical objects to represent Java. So students would be familiar with seeing something like this, but we add some changes. So the type of the variable, that here is C1, the type of the variable is cat. C2, the type of the variable is cat. Before we get to inheritance, we don't have the little post-it notes that label that there's a cat, the variable's type is cat. Then the type of the object, that's on the right-hand side. So we have a cat, or C2 is null. It's a variable that could reference a cat. That's the type of the variable, but it doesn't reference a cat. And again, these pieces are really important for inheritance, but not before inheritance typically. We also try to repeat key phrases to emphasize key ideas. So throughout our instructional sequence, we use the following key phrases. So there's a difference between the type of a variable and the type of the object. You just saw that one. When we call a method on an object, we look in the objects class to find the code for the method. A class can extend another class to reduce redundant code, and an extending class can add methods, inherit methods, or override methods. If we do not find a method in a class, we look in the parents class. The type of the variable determines what methods can be called. The type of the object determines what method is called. Okay, so this is actually just a subset of our phrases, and actually we've developed key phrases for all of APCSA, and you can find that at tinyurl.com/Java anchor code. And the key thing is that Java has so much vocabulary. We want to be really consistent in how we use these phrases and these key terms so that students can start to recall them and use them in their own discussion. Okay, tip 3, introduce intended behavior and examples. So here we have students trace code without inheritance. So we've got a cat class and a tiger class that does not have inheritance. We've got a little diagram on the bottom left, and then on the bottom right, we've got the code that they trace. That just has them trace through all the code. Okay, and this is just to get them familiar with the behavior. Tip 4, super related, is try to make the behavior easy to memorize. That maybe is controversial. We think, memorizing is a little bit weird, but the extent to which they can remember what the behavior should be can help when they're doing inheritance, we think. So we have in our example a unique say hello, but not a sleep method. So a cat and a tiger sleep in the same way, but they say hello in different ways. A cat says purr, a tiger says roar. Hopefully that's intuitive and easier to memorize. And then tigers, but not cats, have a swim method. Okay, and then we also have a grandchild class, Cartoon Tiger, and we use their Tigger from Winnie the Pooh. Not all of our students know about that, but we introduce that character and that it says, hoo 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 hoo. When we assess students, we might use less contextualized examples to see if they can really explore and understand the different ways that inheritance works. But when we want to introduce this stuff, we want it to be as intuitive as possible. And so trying to give them code and behavior that functionally they can memorize quickly is really important. And again, all this starts off without inheritance. Okay, tip 5, show the parent-child methods side by side. So one of our sentences is a class can extend another class. Okay, so here we've got the tiger class that extends cat. And you can see when we start showing it with inheritance, we actually just erase that sleep method because here tiger inherits the sleep method of the parent. Here, tiger overrides the method of the parent, and then it adds that method swim. Similarly, cartoon tiger extends tiger. It inherits the sleep method from its grandparent. It overrides the say hello method of its parent, and then it inherits the method of its parent for swim. So we think having these shown side by side can be really helpful to help students understand what isn't necessary. And when we smush it together, I think it's much harder for students to figure out those missing pieces. Tip 6, we delay instance variables and constructors. So our goal is to have as few lines of code as possible. And so based upon that, all of our methods print text and do not modify states. And again, we initially call, but we don't show default constructors. You can see that in our code examples below. Tip 7, delay inheritance hierarchies that branch. So our goal, again, is to have as few lines of code as possible. And so when we start, we only use a single hierarchy of parent, child, and grandchild classes to introduce inheritance methods. And then we're able to build on that foundation for other things like calling super, etc. Tip 8, do not answer what if questions. It's really, really common that students will say, we'll show an example, and then students will say, but what if? There is no way to assume that I know what they're thinking. And certainly the students in my classroom can't follow that complex what if scenario that the students are presenting. So our goal is to encourage student curiosity without answering questions incorrectly or excluding other students. So we encourage students to use Java to answer their questions. And maybe this last tip is the most important when you're teaching inheritance. It's great that students are curious, but without being able to look at exact code, we can't make sure that their question and our answer is accessible to all the students in our classroom. Okay, that's it. We hope that you'll check out our resources on csteachingtips.org/3D. And one more thank you to my co-authors. Their experiences teaching math and computer science at the high school level has contributed so much to this collaboration, and I've become a much better teacher through collaborating with them. They totally rock. Thanks.